Alright, so welcome back to another video, a presentation on here, Lab 4, Second Hack, Part 1. So obviously it's from GCU CYB 610. So this is the first part of the outline, or the first part of the presentation outline. So it'd be target enumeration on Chioptrix level 2, Nikto utilization, OWASP zap, Nikto versus OWASP zap. So the differences between the two, CSRF summary, XSS summary, Nessus utilization, and I will show you the 10 vulnerabilities. So these next slides will be of excuse me, of the Chioptrix 2 VM enumeration through the video that I watched on there. So this screenshot shows the nmap scan. Obviously, I've config, and I already went through that stuff, so that way I can just see the machine that I need. So what I did is on nmap, I did nmap 10.0.2.0/24 to view all the ones that are connected to my network, and with the open ports, which obviously 10.0.2.15 has the open ports. So that one I will suspect that will be Chioptrix 2. So next, because obviously that's the one that I picked. That's when I know that should be it. So what I did is I used apt get install Nikto, so I could install Nikto, which I believe I already had it installed. That's why it's 0 upgrade, 0 newly installed, 0 to remove, and 417 not upgraded. So then I used Nikto Tech H 10.0.2.15. That is a Chioptrix 2 machine to scan the machine for the vulnerabilities. So after doing that, it showed me a bunch of vulnerabilities on here. So the main ones like anti-clickjacking, X-frame options, header is not present. Now obviously these all do different things. So allowed HTTP methods, get, head, most, options, and trace. Web server returns a valid response with junk HTTP methods, which may cause false positives, and so on and so forth. So next we went into using OWASP zap. So this is the OWASP zap utilization. So I started an automated scan. So if you go into there and you click on the new scan, and it's automated scan or manual scan. So I do automated scan. That way it just runs. And then I use the IP address of my Chioptrix VM or Chioptrix 2 VM, which is 10.0.2.15. And then obviously after it was done, it had a bunch of different ones that were not found according to the active scan, which obviously in this one was done, but according to the active scan portion of it. So we went over to the spider tab, and it does show those ones were actually found. So the 10.0.2.15, then the robots.text /sitemap.xml, and the site index.php. So I didn't highlight all these, but this is like one of the main ones, kind of what I focus on. The SQL injections, like the main ones, like the red flag, like the main red flag alert was SQL injection, possible on here, so active, obviously. So, and this one just shows that I ran the scan, and it's in the history as well. If you go to the history tab, you click on there, and it shows it was connected on 211, 10:57 a.m. And yes, highest alert was medium. So, okay, so after that, for Nessus, I had to kind of go through and find a couple of videos on it and stuff like that in order to install it, or to get to work. So what I used was /bin/systemctl start nessus d.service, and then I went to the URL https://kali:8834/ and then it starts Nessus. I went through the registration process, got my activation code, the activation key, whichever you want to call it, kind of like Windows. And once I registered, I had to use a business email, by the way, so I used my GCU email for that as well, because obviously I couldn't use regular email. So then it registered and downloaded the package on there, and to do that, I went through all that stuff, and then so it took me about 15 minutes or so, or maybe 20 minutes for it to load all of the files. There's a bunch of stuff that has to download. So once it did that, I created a new scan on here, and I just named it based on the video Solzer underscore Chioptrix underscore 2. Then the screenshot shows utilizing the Nessus scan. So this is it completed already, but obviously it ran. It found 2 of the red, 2 critical, 27 high, 22 medium, 5 low, and then there was 37 just informational ones. So obviously it's very helpful. You can go through there and just see, okay, this is critical. Oh, okay, this is just information. It's pretty interesting. So obviously this is the shows the vulnerabilities in here, the PHP unsupported, the multiple vulnerabilities again, CGI query, string code execution, multiple vulnerabilities, and so on. There's a bunch of vulnerabilities on here. Well, there's 21 on here, so there's the critical and then there's a bunch of high. So, Nikto versus OWASP. So, they're both open source web vulnerability scanners. That's why we use it on Kali Linux, because Kali Linux obviously is an open source OS. So they're both used to identify security vulnerabilities in web applications, and obviously, obviously on Chioptrix, you can see the vulnerabilities on it as well. So there are some differences between the two tools. So Nikto is a command line tool. It's designed to be used by security professionals. It has a large database of known vulnerabilities, and it can also be used to scan a wide range of mobile applications. OWASP is a graphical interface or user interface GUI tool designed to be used by both security professionals and also non-technical users. So if you're just like want to do a scan, you can do that. I thought they were both very easy to use. I've used them both before prior to this course, so they're really not that hard to use. But anyways, so it has a smaller database of known vulnerabilities in Nikto, so it's not as complex, but it still gets the job done. It primarily uses to scan web applications that are developed using the OWASP framework, so it can detect vulnerabilities in its own makings. So CSRF summary. So CSRF is cross-site request forgery. Is a web security vulnerability where an attacker it tricks the victim into performing actions on a website, so clicking or entering passwords, so on and so forth, without their knowledge or consent. So obviously it's hacking, right? So it's unethical hacking. So CSRF works when the attacker creates a link, image or code or something that you click on, like a hyperlink kind of thing, that triggers a website action. For example, you click on a link to change a password, and now they have your information because you just did that. So essentially works because the user is a normal user of their account, which they can gain access to. Obviously they can gain access to their account easily. Your bank account, you go to Bank of America or whatever, and you click on a link to go to it, and they already injected that CSRF on there, that link on there, and now they can essentially check what you're doing, and you have your password as password1234. Now they know your password 1234. Your name is John Smith. They know all your information. They know all your stuff. So you gotta be careful. So this is the second part of it. I split them up just because it was just easier for me to do. That way you can see the first part of it and then the second part of it. Kind of has to do with each other. So the second part is going to be flaw hypothesis and findings, vulnerability analysis, tools and techniques identification, attack vector hypothesis, legal or ethical and industry standard, and then vulnerability in depth hypothesis. So based on the findings, I conducted using Kali Linux VM and Chioptrix 2 VM. I found that there are obviously many flaws using OWASP and Nikto both. And Nessus, I saw there's SQL injection, anti-CSRF tokens, but they're not used. Content security policy not set, end page banner information leak, and there's tons of other that can be used to exploit, which obviously is the point of CyberX 2, but obviously a regular system would not be good. So using OS app, it helped to find security vulnerabilities in web applications, and of course, um, during the CyberX 2 enumeration kind of, I did find obviously a lot of those. You saw on the screenshots, and one of the main ones I found was like this SQL injection and all the PHP errors and everything. So using Nikto, I found obviously anti-clickjacking, X-frame options, header not present, junk as it said on there, HTTP methods found, and a ton of other vulnerabilities as per the screenshots. So tool and technique identification. So obviously to mitigate these, you can do penetration testing, security code review, threat intelligence, cybersecurity analysts, cyber intel analysts, kind of thing, penetration testing. I don't know why I have that twice. I apologize, but I have that all on there twice. I apologize, but yes. So attack vector hypothesis. So SQL injection is a covert type of cyber attack in which a hacker inserts their own code into a website to breach its security measures and access protected data. So once inside, they control the websites and essentially they hijack the information that's in the website. This to me would be the easiest attack vector within the vulnerabilities found in the CyberX 2 system, and then which obviously is the point of it, like I said before. So the PHP unsupported version, which usually contains security vulnerabilities due to it being out of date, is another one as well. So legal, ethical, and industry standards. So copyright and intellectual property laws for legal considerations, computer fraud and abuse laws, and then obviously data privacy laws. So ethical considerations, responsible disclosure. So notifying the affected party before public disclosure allows them time to fix a vulnerability, minimizing harm. Minimizing harm. Public disclosure. It just said that again, but I thought I would kind of reiterate that. User privacy. So obviously during these attacks, the privacy is exploited and it's blown out of proportion, unfortunately. So industry standards. So the CVE system. It tracks and shares vulnerabilities globally, so that way everybody knows about that. So it assigns common vulnerability IDs. Responsible disclosure frameworks. Organizations like CERT and FIRST provide guidelines for ethical vulnerability disclosure. Industry-specific practices. So different industries, they have different requirements, SOPs, and so on and so forth, and regulations based on like the business or just whatever. The government has different ones than like a Walmart cybersecurity would, or than Intel would, or other companies and other lines of those. So vulnerability is openly used and detected. It should be disclosed to the public. To me, that's what my kind of hypothesis on this is. So that way, everyone that's obviously in the industry can watch out, and make note of that attack or that specific issue. So, a little background on SQL injection exploit. It was first discovered and detected in 1998 by cybersecurity researcher and hacker Jeff Forstall. His findings were published in the long-running Hacker Sein Frack. Essentially, there are three root causes of SQL injection. So the root cause, there's combining of data encoded in dynamic SQL statement, error revelation, and this insufficient input validation. So those are the main root causes of it. All right, so this is my resource page for the resource I had, and that is the end of my presentation. Thank you so much.